Okay, let's discuss phase diagrams. A phase diagram is going to be a graph that's going to summarize the state of matter of a particular substance under various conditions of pressure and temperature. And you see here on this graph, we have pressure on the y-axis in units of atmospheres, and we have temperature on the x-axis in units of degrees Celsius. And so we can just pick, I'll just pick some random temperature here. We'll say this is, we'll say like 120 degrees Celsius. And so by looking at the intersection of 120 degrees Celsius and 1 atmosphere, let's see where that would be. Let's put this here like that, 1 atmosphere straight across, take 120 up. So this point right here would represent the phase of this general substance at a temperature of 120 degrees Celsius and a pressure of 1 atmosphere. And we'd say under those conditions, this particular substance would be in the gas phase, because that's the region of the graph under which it falls. We can take other positions on the phase diagram. We could say, well, let's try, we'll call this here 0 degrees Celsius. And we could say maybe we're at 2 atmosphere pressure. And we could look at the intersection of 2 atmospheres and 0 degrees Celsius, which would be right here. And we'd be able to say, all right, at 0 degrees Celsius and 2 atmosphere pressure, this particular substance would then be in the liquid phase. And of course, if it was going to go from this point to this point, it would have to undergo boiling, because it would go from the liquid to the gas phase. So here are a couple questions for us to think about. We could say, you know, what is the boiling point of this substance? What is this boiling point? Now that's going to be the point at atmospheric pressure, 1 atmosphere pressure, at which the substance goes from a liquid to a gas. So at 1 atmosphere pressure, where does this substance go from a liquid to a gas? It's going to be right about here. And so on 1 atmosphere pressure, where the substance goes from a liquid to a gas, if we were to drop this line straight down, this would be the boiling point, the temperature of the boiling point of that particular substance. And if this was to scale, which I don't know if it is or not, but if this was to scale, we'd say that's roughly 100 degrees Celsius in this particular case. We could also ask the question, at what particular temperature would this substance melt or freeze? What's the freezing point? What's the melting point? Well, once again, we can take our 1 atmosphere line, draw it straight across. We see right here is where this particular substance goes from a solid to a liquid or a liquid to a gas. If we drop that line straight down, that looks like it's at about 0 degrees Celsius. So this would be the freezing point, the temperature of the freezing point of that particular substance. And this is probably water then, because we know the boiling point of water is 100 degrees Celsius and the freezing point of water is 0 degrees Celsius. It's likely that this particular compound would be water. There's also another clue here that this substance is water, and this is a little tricky. But let's imagine we have, we'll call this water, okay? So we have some ice, and that ice is below 0 Celsius, it's below the freezing point, and it's at 1 atmosphere pressure. So it's a little lower than 0 Celsius. It's below the freezing point. It's at 1 atmosphere pressure. It's, sitting outside, maybe on a sidewalk or something. And what we would do is we imagine we're going to stay at this temperature and we are going to apply pressure to the solid. So again, we're going to stay at the same temperature. So that means we're going to stay along this line. And we're going to apply pressure to the ice, which means the pressure is going to go up. All right? And we see if we did this kind of change, where we increase the pressure on the ice, we would actually move from the solid to the liquid phase. So by applying pressure to ice, we'd see that we'd get the ice to melt. And this is a curious feature of water. Water and a few other substances do this, where if you actually apply pressure to the solid, you move to the liquid phase. It's usually the opposite case. It is usually the opposite case that when you apply pressure to the liquid, a solid forms. Now, how might that look on a particular phase diagram for a substance that does the opposite of water? So most substances have a phase diagram where the solid liquid line leans in this direction. So in this case, if we have a liquid at a particular temperature, we keep that temperature constant and we increase the pressure, we see that the liquid is going to go to a solid when pressure is applied at constant temperature. So that solid liquid line on the phase diagram leans this way to the right. With water, it's an odd substance where that solid liquid line phase boundary leans to the left. And when you get something like that, you'll have a substance that actually undergoes melting when you apply pressure to the solid.